Good day, this is Jim Pytel from Columbia Gorge Community College, Renewable Energy Technology Program. This is Digital 2, EET 122. Today we're going to have a discussion about up-down counters. So we've already shown by using different types of flip-flops that are triggered on either a positive edge or a negative edge, we can create up or down counters depending on our needs. So consider these two asynchronous counters here. One using positive edge flip-flops. One is using negative edge flip-flops. So a positive edge flip-flop, Q0, Q1, this being Q0, that being Q1, positive edges. So, and again, we're assuming all these guys for each one of these states, because again, we're dealing with asynchronous. They're always in toggle mode. Same thing for this diagram right here. So for a positive edge flip-flop, what's going to happen is Q0 is going to toggle every positive edge, assuming it was a 0. Oops. Okay, and Q1, which is this guy, the output of the second flip-flop, that's going to toggle every positive edge of Q0. So what we've created here is a down counter, where it's 1, 1 to 1, 0 to 0, 1 to 0, 0, recycling back up to 1, 1. So again, we're counting down to 0, recycling to 1, 1. We can draw a recycle like that. Okay, now using our negative edge flip-flops, again, this should not come as a terrible surprise to you. And this guy, each stage is in toggle mode. J and K is hooked up to +5. There's Q0. Q1, we're on the negative edges. We'll even use the same clock signal. So Q0 is going to toggle every negative edge. And Q1 is going to toggle on every negative edge of Q0. So what have we created here? Well, this is an up counter. This is going from 0, 0, 0, 1, 1, 0, 1, 1, 0, 0, and so on and so forth. So we're progressing to these states, recycling back to the beginning. So that's an up. This guy was a down. We can already do this. But now, I know it's nice to have a hammer and a screwdriver, but wouldn't you rather have just carry a single tool, like maybe a screwdriver you can use as a hammer? And I know you've all done that before. So basically, what we want to do is create a counter that can count either up or down whenever you want it to. Okay? So our desired sequence, let's say we are in up mode. Let's use a 3-bit counter, up mode. Then it's going to recycle. That's our up mode. And our down mode, yeah, I know I switched colors. That's okay. Down mode, we're going to start at 111 and go down. And we recycle. Okay, so when it's an up mode, it does this sequence. when it's in down mode, it does this sequence. And say, for example, we're in up mode, counting along. Let's say we're in up mode. 0, 1, 2, 3, 4, and all of a sudden we switch to down mode right in the middle of a count. What happens to down mode? 3, 2, 1, 0. Recycles to 7, 6, 5. All of a sudden we switch to up mode. 4, switch to up mode. 6, 7, 0, 1. So basically we can switch our directions in midstream. So this is a far more versatile counter than these two, which we just drew right here. These two require hardware differences, and the counter that we want to do, it's going to have basically a very versatile counter that not only goes up but down and can change direction in midstream if we tell it to. So ideally, we'll never be asking our counter to simultaneously count up and down because that wouldn't make sense. So all we really need is just one command. And that one command, let's just call it up. And when up is 1, it's counting as an up counter. And when it's down, when it's 0, it's a down counter. Okay? So you could, for all intents and purposes, consider anytime you give a 0, that means you want it to go as a down counter. That's almost kind of like giving it an active low. So oftentimes you'll see down with a bar over it, indicating if you want it to go down, you need to give it an active low, i.e. a 0. Okay? So let's keep things a little simpler now. We're going to do a 2-bit up-down counter. So for our 2-bit up-down counter, when we're given the command up, i.e. up equals 1, our sequence should be going from 0, 0 to 0, 1 to 1, 0 to 1, 1, recycling. Okay? And this being our LSB, that's our MSB. So now when it's in down, when up equals 0, or we're giving down an active low, what's the desired sequence? 1, 1, 1, 0, 0, 1, 0, 0. Recycling back up. Okay, so Q0, that guy right there. And again, let's do synchronous counters. Synchronous counters, same clock. So all our bits are changing at the same time. Okay, for either up or down counter, Q0 is toggling every single time. Notice how it goes from 0 to 1 to 0 to 1 for when you're in down mode, 1 to 0 to 1 to 0. So really nothing has changed for bit Q0, and that is always going to be in toggle mode, regardless if it's an up or a down counter mode. Okay, and this, by the way, that's Q1. The trick is this guy. When does the second stage flip-flop go into toggle mode? Well, for an up counter, it toggles right here. Now I'm going to use a different color so you can see that. It's toggling right there. So it's toggling when the command up is given and Q0 of the previous stage is 1. Because if you think about it, when else does it toggle? Well, it toggles on the recycle. And yes, it's bringing it back up top right here to 0, 0, but I'm just going to draw that down below, 0, 0. Just to illustrate the fact that it's toggled here, toggled again. So when does it toggle? Well, obviously when the command up is given and the previous stage of Q0 is high. So if we were going to have an up counter, we would expect Q0 and up. We want it to toggle then for this second stage. But that's only for an up counter. We have to account for the down counter. And for the down counter, let's switch to red. So down counter, when does Q0 toggle? Well, it's always toggling, as we've previously illustrated. When does Q1 toggle? And I'm going to illustrate the recycle right there. Well, Q1 toggles right here and right here. So whenever the previous stage was 0 and up was a 0, okay? Or not down was a 0. I know it's active low. Your head is exploding there right now. Okay, so I can illustrate that, simplify this by doing this. Again, when the previous stage, Q0, was a 0 and not up. Okay, why didn't I use down there? I could use down, but knowing that down is not up, this is basically ensuring that I'm getting a 1 here. And that's why I'm doing not Q, because it's a 0. Because the key to the whole thing, the unifying feature, it's toggling in up mode when Q0 and up, or when not Q and down. Okay, so the expression for the toggling of this second stage here, Q0 and up, or not Q0 and not up, because there really is only a single command up or down. It's not like you're going to have two inputs up and down. Okay, so you could just negate up to get down. Okay, so we can expand this idea to a 3-bit counter very easily. But before that, we should actually go ahead and do the logical implementation there. So basically all that logic gate arrangement there is this funny trick to get that thing to toggle whenever we want it to. Again, when we want it to, when previous stage Q0 and up, or not Q0 and not up. Okay, so going back to our 3-bit counter, which I'm going to draw another third flip-flop in here. And there's our third flip-flop. And again, let's do our up and down sequences. Up, down. And there's our sequences. And again, we recycle and we recycle. And just for analysis purposes, I'm going to put the recycle below here so we can talk about, in our particular case, we've already figured out we already figured out Q0, this being the Q0 column. It's still toggling every single time. So that means first stage, always going to be in toggle mode. And we just figured out Q1 in our previous example. Q1 is going to toggle when it's in the up mode and the previous bit has been a 1, or we're going to toggle in the down mode when the previous bit has been a 0. Okay, so Q2, that's our item of concern. So looks like Q2 as an up counter, it's toggling right here and right there. So when all three previous stages are ones and we're in the up mode, that's when we toggle right there and right there. Same thing goes for the down counter. It toggles here and here. So in all three previous stages are zero, excuse me, all two previous stages are zeros. And we're in the down mode. So it's a very simple logic arrangement as we did previously. So it toggles in the up position when we're given the up command, and Q1 and Q0 or 1, or it's toggling when previous stages Q1 and Q0 are zeros, and we're given the down command, which is again not up. So we could put that logic arrangement right up there, and we could extend this onto 4 bits, and we could extend it onto 5 bits, 6 bits, whatever. You get the picture. Basically, you're making a very versatile counter by tricking it when to toggle and taking into account the modes, up or down. So let's talk about a pretty useful device, the 74190. Okay, this is an up-down synchronous decade counter. Okay, we previously discussed the 74163, which was a synchronous 4-bit counter, but it wasn't a decade counter. So 4 bits, you can go up to 15, you got to go back down to 0. But remember, that was just an up counter. This guy's an up-down counter, very versatile. Okay, so we may have also talked about the 74160, which is again just a synchronous counter, but that was a synchronous decade counter. So these guys are very similar, the 74163 and the 74160, very similar to this guy that we're talking about right here, the 74190. So the similarities, it's synchronous, it's a counter, it's got a data in. Let's just draw a box here. So it's got these data ins. D3, D2, D1, D0, and it's still got that same active low load. So these guys just hang out here until you get an active low load signal, and that's basically presets your starting number. Okay, so you can start counting up from 4. You can start counting down from 4. You can start counting up from 7, start counting down from 7. Doesn't matter. Basically, as long as you give it an active low load, it's going to take this number. Say we're going to count from 4. Just put that into D3, D2, D1, D0. Give it an active low. It's going to start at 4, whether you're in up or down mode. If you don't give the active low load, those guys are just dangling there and doing nothing. Okay. So we already told it it's a synchronous. It's got the data in. It's got the active low load. Obviously, it's got a clock. Yeah. So everybody's got a clock. It's got the enable commands. This is basically a count enable. Go ahead, start counting. And then it's got this max and min out. Very similar to our 74163s, and telling it's reached the end of its sequence. If it's in down counting mode, obviously it's going to go high when it's reached the output quadruple 0, and that max min output is again going to go high if it's in the up counter mode when it's reached its maximum. And tricky question, what's the maximum for a decade counter? It's not quadruple 1 for a decade counter. Its maximum is 1001, because remember, BCD, binary code decimal, goes from quadruple 0 to 1001. Okay, so there's also another output, RCO. That's a ripple counter output. That's used for cascading counters if you want to count greater than 10, and we'll go into that, I almost think, in the next lecture. Obviously, yeah, you got your outs, Q3, Q2, Q1, Q0, and that's our counts right there. So what's different about these guys? These are all kind of the same as our previous counters there. Well, the only thing that's really different about this guy is this input here. It's a down, up. So I know a little bit different than what we've previously been dealing with, but counts down when it's a 1, counts up when that input is a 0. And you can change that at any time you want to. Okay, so this is a quick discussion about up and down counters, up and down synchronous counters particularly. Very useful devices. You can count up or down or change midstream. And chips like the 74190, you can have these preset datas. There is other chips very similar to this, 74191 I'm thinking about also. That is not a decade counter. That's a 4-bit binary counter, so you can count up to 15. There's 74 192s and 193s, and those are respectively a decade counter and a binary counter, but they've got a clear. That's all it does, is just add a clear function to it. Okay, so we are going to move on, and I think we're going to go to cascading counters.